Hi, my name is Zachary Angelot, and I just wanted to go over more stuff that I've been doing to my project. Um, there wasn't a whole lot of changes as far as new stuff. I was working on some newer stuff, but I decided to kind of pull it out last second. Basically, I was trying to kind of implement RAG, which is basically its ability to read information from outside source. It kind of already does that with model training in my data, but I was just going to try and do it in a different format, or maybe be able to read paragraphs and stuff. Anyways, what I kind of was working on a little bit before then was in my last video was working. It was running a little bit slow. It was taking like, I don't know, 20 seconds or something like that. And now it seems to run a whole lot quicker. Around like 10 seconds now, depending how quickly I type it or whatever. But yeah, still does the intent thing and everything. But what I wanted to show you was what I was doing to try and get down its memory and its allocation. You would just run this command and basically pprof, and it generates some profiles. Basically these files like CPU and then mem and then block. And so what you can kind of do with them, and it'll give you kind of a readout too of allocations and memory and how fast and everything. So what you can do with these files is, if I come across, there we go. That was basically turned into a PDF, but you could run pprof on those profiles. And so you get kind of a list of commands in order to be able to see that. One of them is top, and this kind of lets you see what files and how fast they're running and how much they're taking up and everything. You can also get a kind of what is the top most used, I guess you could say, or maybe nodes that it uses, or it's top performing, well, not performing, but it's top CPU intensive functions. And from here you can basically grab one and run list, and it'll give you, okay, so it ran quite a while on this function, but this function, it's getting intent, so there's kind of a lot behind this function and why it's taking like 5 seconds the CPU time. And so you would have to go into here then, and then, oh, maybe it didn't like that. Maybe I gotta get rid of the IC. There we go. And you can look inside that function and see how much of it was using CPU time, and now you got this one. And so, what's this one running or whatever, and you can open up that one and see, generally speaking, what's taken up all the time. And it looks like it's this line. And so why is this line now taking up that much time? And you go into it and it's now this line. And so you kind of break it down, break it down, break it down, break it down. You do gotta remember though, you kind of have to take this with a grain of salt, only because it depends how you run it, what else is running, just lots of stuff, kind of. It may, like, I had a function that, like, compared two things and then ran a little range loop, and it was taking up like 5 seconds, and I was like, that's all I was doing. Well, depends what it's comparing. Is it comparing a slice of a slice? You know, so you kind of have to dig and look and have some kind of context behind what it is that you're comparing and looking for and everything. I know there's kind of a want to, like, take this and then throw it into your Gemini and then ask Gemini, how can you fix this or whatever, but I think that might be a bad idea. Just because until you get down to what that is and why and what it's doing and why it's trying to do it, I just don't think optimizing it like that is a good idea. Another thing you can do is look at memory profiles and everything. How much memory, but again, some of this, oh my gosh, it's taking up all this memory, and then when you go to actually look at it, a lot of times you begin to realize, oh, it's creating a model, a gob file or something, and it's like, oh, well, yeah, that's going to take up a lot of memory, like, because it has to store it all in memory and then write it and everything like that. There's not much you can do about that. There's a lot of other commands you can do, like I was showing with SVGs and everything, but at the end of the day, you really just want to look at your code and kind of try to understand it first before you start just Geminiing the heck out of it, basically. There was the other one. I believe it's block. Yeah, and I think this is block is, I believe, how what's kind of taking up the Go routines and, like, kind of how where are they stopping at, and or using up all their time on. And so it's sort of an interesting way of looking at your program more deeply and easily. But in order to do all that, you do need to set up the test file. I mean, there's ways of doing pprof without a test file, but the things you have to set up, you're not going to want to but clutter your main program with all this benchmark stuff. Like, why would you do that? So it's kind of nice to have this file laying around here with main that allows you to kind of dig. You don't have to do it on main. You could do it on individual files, obviously, but then the problem is you're always gonna, like, end up redoing this, or you may do both, and you may run both, and you may want to kind of see directly, okay, if I just run this one function, what am I getting and why? Or if I have a new idea, what's another way to eliminate allocation or whatever running this loop, and so sometimes it is helpful to have individual test files just to be able to mental model out what's going on and why. But I think these bigger ones are nice in that it kind of gives you a real broad view of what's going on, why, and how to deal with it and everything. Some of it, like I said, is fake in a sense. Well, not fake, but just not as pronounced as you would think this is, really, because so many things get in the way, or it's creating certain files, or it's reading certain files, and so doing the main test can be bad because you're kind of putting it all in, and it may not be that big of a deal. So running it on only certain functions may actually be a lot more beneficial because you don't have to deal with that mess of maybe fake stuff or clutter or whatever. And or maybe your program's huge and, getting to the nuts and bolts of what's actually doing, taking up the most memory or whatever may just be a lot easier to do on individual files and everything. I already pushed all this up so you kind of take a look or whatever. So yeah, and I did it on a hard-coded command. You can do it with input, and then you could type it in or whatever. But I feel like if you're gonna be benchmarking and then you're waiting for the input, it's sort of not. You're not looking at how the program runs. You're just kind of getting a broad view of output and input, and that may not be again what you want to deal with. But running it this way though too, you may actually come across things that are actual problems and may end up costing a lot of time, and it may just be written wrong. And this can kind of give you insight into, what did you do? Some of this stuff though, like this, is like channels, and you can't change that. That's internal runtime, and there's just nothing you can do about that. Or like weight group, that's obviously, I guess it depends what kind of code you're running that might affect these, but you get the idea. Anyways, yeah, I was just trying to make it quicker or whatever. And one thing that I learned kind of to do is when you do run the benchmark, go back to the top if I didn't clear it, is to kind of maybe write this down and then compare it to maybe a previous one, and maybe the changes you made it worse. You know what I mean? It may have. You may have optimized that little part of it, but then the program as a whole might be allocating a lot more. Or whatever, like this one, it used to run faster. Now it runs a bit slower. It just depends what you're doing, what you're adding, and how you're changing it, and all that. So I just wanted to show that because I thought it was interesting, and it really sped up my program and helped me out a lot. And it's just pprof. You can go to Gemini and prof commands, and it'll spit out what they are, or it'll try to run them. Can you explain the commands? Or it'll just outright ignore you. But yeah, so, okay, now it's doing it. So I didn't memorize all the commands. Yeah, I basically went over the stuff that I already kind of explained. That's where I learned it from, kind of, was this. I'm sure there's some frameworks or whatever that make this 1,000 times easier and quicker and better and everything. Whatever. I'm just getting started with that. I never really needed it before because, you build a little program and it runs pretty instantly and you don't really think about it. But when you have neural networks learning and everything, and you have a lot of loops, some of this stuff, no, that's all checking. I guess if you got into the nitty gritty of I think that was some of the stuff I optimized. Actually, I think it was, or may or may not have been. Yeah, these things can always be kind of optimized, and there can just be like little tricks where you're using maybe iterators and or like booleans and everything to kind of not allocate the heck out of stuff because it is loop in a loop, you know. But you are going through a matrix of columns and rows, and being able to do it quicker or less allocation makes a huge difference with how the program runs. So, but it may come at a cost of readability a bit. But I'll be honest, not too many people are going to want to touch these loops as is, and that's about as clean as it is gonna get, right? A loop in a loop. I mean, you're not gonna get any more cleaner than that. Usually they just pack this away into a function, and then nobody looks at it ever again. But to be able to optimize it then, and then have it be that function, hey, that's great. So, I mean that, I guess that's what I've been working on, why and everything. Yeah. Like I said, the next thing I was gonna try and do was trying to do that RAG, RAG, where it attempts to look at outside information, or just paragraphs instead of JSON. Or maybe I'll make the paragraphs JSON. I don't know. I was looking up more machine learning stuff at different like academies on YouTube and everything, and some of it made sense. Some of it I think is a bad idea, just allocation wise, because they want you to do these trees and the child nodes, and with intent, you got to be really careful with that, because you just don't want to allocate the living heck out of stuff. And also, if you go down the road of intent, I understand that you want to keep the scope of the intent a certain way, otherwise, well, you kind of are dealing with LLM type problems, and that's not really what I want to deal with. But the problem is, if you scope it with nodes and trees and everything, it gets really dumb. Even though it's doing all this training and learning and tagging and whatnot, if you structure it down to like the index, or use a certain word or whatever, you're defeating the point, sort of. You want it to understand intent, at least from a higher level, not based on specific words. Not everybody talks the same way, not everybody types in commands the same way, so on and so forth. So you want to keep it, I think the word abstract is a bad way to put it. I think it's more like a step up in intent, like contextual intent. And in doing so, you don't have to worry about the words as much. It always comes down to a certain level. It has to understand words, but when you have all these programs kind of stacked with, like I went over on the rest of my videos, with context and tagging all that, you can kind of get away with not having to create all these trees and stuff like that. Eventually, it has to kind of come down to understanding what an idea is to a certain degree, right? You can't just, it ain't gonna innately know you before you write your input, right? But you can have the code kind of work for you to better guess maybe what kind of intent or general intent that you're going for, and from there you can work out whatever it is that you want it to be. This way, you know, and yeah, this would be 10 times harder in another language, or if you're doing multiple, I shouldn't say in another language, but if you're doing multiple languages, that would be epically hard, because then there has to be some middle ground, and there has to be some kind of language, computer language that, they kind of get converted into. And, I'm just not going to deal with that. I'd much rather, I know English, I understand English, I can sense when things are wrong, I can use my intuition with intent, so on and so forth. So that's just, I'm not going to muddle things because somebody wants it in some random language or whatever, and it's nothing like English, and so all this may not make a whole lot of sense. Well, I don't know what to tell you. But yeah, so if you have any questions or anything, let me know. I'll put the link to the GitHub for it and everything. Yeah, that's all. Thank you.